Well, hello everyone. This is KP the Math G here. Ready to do another video. I've been watching to see how many people are tuning in, and I'm getting quite a good response, especially from those who, whenever I give a lesson based on one of the tests that the College Board puts out for a free response. It is open to the public. You can use that if you wanted to. But anyway, I just go through the years and find one and that I felt like I haven't done before, and I just put one up there. And if you want that, just let me know in the comment section that you would like to see more of those, because I know that for those of you who are in the AP class, that your mock test is right around the corner. And as for calculus students, you just might want a briefing on it to see where you are with it. So keep those things in mind. I put together several videos. Well, actually not. Several lessons for videos, upcoming videos. And what I'll do is that occasionally I'll put up some things that are from a textbook, and then I will put up some problems from, say, 2002 or 2010 or something like that, and question number 3 or something like that. So anyway, let's look at this question. Look what we're talking about here. This is integration by parts. This is probably not part of the A-B section. It's more into the BC, probably, I think. So let's get started anyway. And you might want to get into this whether you are in the AB or the BC. It doesn't matter. There is a formula that you can use to do this. Integrating u dv is equal to u times v times the integral v du. Alright, and we have an example here. And what we have to do here, guys and girls and men and women, is we have to let u be equal to something, and then we have to let also somewhere over here let dv equal something. Okay, and that's how you start this problem. There's no way that you can just use a regular way that I know of and integrate this without doing this by parts. Okay, and I already did this several days ago, so I've got to kind of see what I did with that. Alright, yes. Alright, we want to find something that we can find the derivative of easily. I don't think we could see. This is integrating here. This is your integrating part here. This is your derivative part here. Okay, so you want to either pick this one or this one and all of this. If you pick this to be your dv, okay, this was going to be u. If you pick this to be u, this will be dv. But since it's easy to integrate or to find the derivative of ln x, I want u to be equal to just that. I want u to be equal to ln x. Alright, we got to account for everything. I want dv to be, let's see how I put that down. Okay, yes, x squared dx. so that's what we're doing. We're integrating the easy part. We're taking the derivative of the easy part. I know what du is. Du is, we got to know what our derivatives of ln and other things, sine, cosine, tangent, and so on are. And you might need to brief over those while you are learning this. Okay, so 1 over x dx, all right. dv, if I were to take this side and then this side, all right, then I know that v is equal to so x cubed over 3, and for the time being we are not going to put plus c right here. We're going to reserve that for later. I think I did everything right. I increased this exponent by 1 and divided by that same exponent. Okay, and again, we're not putting a plus c on any of this right now. Okay, later on at the end of the problem we will do a plus c. Alright, so let's follow the directions here. Let's see, I've got u is ln and v. Alright, so I could do this u times v. I like to put the variable in front of ln. I don't like to put ln first. Alright, so I could, in other words, instead of, well, now let's see, u times dv. U times v, yeah, u times v. Alright, so x cubed, so this equals x cubed over 3 ln of x. So this is actually u times v backwards. Doesn't matter, u times v and v times u. You can do that, can't you? Alright, so that's what I have there. And then now minus, let's stick with the pattern. I want v du. V is here, x cubed over 3. And du is, let's see, what is du? Oh, this is ln. Then du, oh, du. Yeah, yep, that's right. Okay, I had to find it. Okay, so you're using all of these. Okay, all right. U times v, these two together, and then v again, and then du is that. Okay, v du is that. Okay, now we can simplify that a little bit. So let's do that. That's x cubed over 3 ln of x. I'm going to make this is 1/3. I'm going to put this on the outside, so minus 1/3. Integrating. Alright, so now this is x cubed. This is going to be gone. This is going to be x squared now. So just x squared dx. Like that. Everybody see that? So let's see, x cubed, I just put the 1/3 right there, times 1 over x is equal to x cubed over x, which is x squared. Okay, and that's what you have to do there. Okay, all right, I don't need this. Okay, like that. This part here I don't need to worry about. I'm done with that. That's what you do when you work this out on the side just a little bit. Alright, so here we go here. This is x cubed over 3, or 1/3 x cubed ln of x minus 1/3 1/3 1/3 times x cubed over 3, now plus c. and then of course I can clean this up a little bit. So I have x cubed over 3 ln of x times, now 3 times 3 is 9, 1 times x cubed is x cubed, minus sign here. Alright, so x cubed over 9 plus c. Alright, that's it. And one way that you can check this, which I'm not going to do at this point, but you can take the derivative of this and you should get this original back. Okay, and we could take the derivative. I've already done it before, but this is your final answer here. Be aware of that. Okay, alright, I'm going to do one more problem based on this kind of idea. Alright, so let's do it again. Alright, so let's remember, let's see, we're integrating u dv, alright, is equal to u times v minus v du. Okay, it's like the power rule if you want to look at it that way. Alright, okay, so let's look at one more problem and then I'm going to stop this. There are actually two ways to do this problem here, so let me show you both ways. Okay, alright, so let's see, I'm going to integrate here x e to the 2x dx. Okay, now either way, I could probably let u be this, or u be this, or let dv. So we're actually wanting to say, here's u and dv. Always start like that, and that way you won't be lost as to what you need to do. I want u to be x. Then of course if I take the derivative of the left side, that's du. The derivative of the right side is 1, but 1 dx. So du is dx. That's simple enough. Alright, e to the 2x is going to be with dx here. It's going to be that. Alright, so now if we integrate the left side, we have v. Alright, that's what we were looking for. Alright, now I want to show you maybe a shortcut to this if you want to. You know, when you take the derivative of e to the 2x, you are saying, well, anyway, that's sloppy. I'm sorry. That's equal to e to the 2x times 2. But when you integrate, you're multiplying by 1/2. So this is actually 1/2 e. Just do the opposite of times 2. Instead of times 2, and make it 1/2. E still to the 2x, that's still alright. And then we have, that's it right there. Remember, we're not putting a plus c. We could have integrated this, but this is just kind of a shortcut. If you see 2x, this is 1/2. If you had, if you're integrating e to the 1/2 x dx, then this is going to be 2e to the 1/2 x, like that. If you do that, because just flip that over, see, and that's going to be this here, and then this is still 1/2. This still stays the same for e. Okay, does that make sense, everyone? Okay. Alright, so that's what I'm trying to say. You can cut You can make a really good shortcut by doing that. On E functions, that's really easy. Okay, so let's see what we got now. U times V is what we're looking at. So it's equal to U, which is X, times V. Well, V is 1/2 e to the 2x minus sign integrate. Right here. Now I'm down to this. V du. V again. I'm going to put the 1/2 on the outside. Move it over a little bit. 1/2 here. E to the 2x. Alright, what else? V now du is dx. So that's simple there, isn't it? Okay, does everybody see that? Alright. I think I got it down to that. Alright, that is it. Alright, now this is good here. Let's put the 1/2 out in front. So 1/2 x e to the 2x. You can do that. That's a commutative property of multiplication. Now let's look at this part right here, because we're taking the integral of that. So if we integrate e to the 2x dx, well, I know we've already done that, haven't we? Again, that's equal to 1/2 e to the 2x. And again, no plus c for right now. That's what we have here. Alright. So we have a 1/2. That's this part right here. And the rest of this is 1/2 e to the 2x here plus c. And then we can kind of, hold on just a second, let me erase this now. Alright, now, what do we have to do next? Well, 1/2 times 1/2 is 1/4, isn't it? So let's rewrite our final answer here. So 1/2 x e to the 2x. Alright, 1/2 times 1/2 is minus 1/4. Okay, e to the 2x plus c. And that is that. And again, we can take the derivative of this right here, and it is a pretty nice little derivative. But if we take the derivative, we will get this back again. And I have already checked with that, okay, on this one. Alright, there is another method. Now on the first example, it would be difficult to do it, although I think it could be done. You just have to, you can't let u be this, but you could let u be this instead. But you'd have to know how to integrate this, and still you got to integrate this by parts. So this is not conducive to the method that I'm about to tell you about. Well, I'm not going to show it to you today. I'll probably show it to you on the next video. It's called the tabular method. And you can use this very quickly, get this answer using the tabular method. Okay, and I don't know how much time I just ran off this clock, but my old camera there, it just likes to, it has a mind of its own, and it likes to just shut off whenever it so desires. Well, it'll take me up to about 31 minutes. Maybe if I'm lucky, I can get 32 minutes out of it. So I'm trying to keep these videos a little bit shorter. I probably need to get what you call a memory card that can hold more memory, take in more memory. I'm gonna let it go like that for right now. After I do a video and process it, I can erase this and start another video. I didn't have to when I first got the camera, but now I don't know. It's just getting older, and it's taking on less and less memory. All right. Well, anyway, enough of that. Again, please let me know. Say it in your comment in the comment section there, and let me know that you want a problem from the one of the tests, okay? Be it the year 2000, 2004, 2008. All right. Oh my. 2020 for all we care. As long as we can get a problem, that's good with me. Okay. And I'll put it up there for you. So anyway. We are going to continue this. The next time we do this, it's going to be by the tabular or tabulation method. Tabular method, that's what it is. And we'll do that, okay? And then we'll get on to another concept. And I don't know about another one, but then we will start picking up on the test questions for a little bit. Okay, anyway, this is KP the Math G signing off. Please subscribe if you haven't done so already. I'm pleased to see that I'm getting more subscribers. I appreciate that. Please comment if you'd like to comment something, and hit that like button too. That's really encouraging to me. And I trust that, that really helps me to really say, hey, I must be doing something pretty good here and pretty special for you guys, okay? It's not all about me, it's about you. All right, anyway, KP the Math G signing off. Have a great day.